Hello everyone, this is Gayat Amaturo from Botenka University Civil Engineering Department. So in this video, I'll be showcasing to you guys how to design a retaining wall with regards to foundation engineering using the Geo5 software. So now let's head over to see the question and let's move on. So the question looks like this, where we have a retaining wall made up of concrete, as you can see, having a base of 3.5 meters and is supporting a soil with the following parameters, as you guys can see. It's also having a soil beneath the base, which also have the following parameters, as you guys can see on my screen. So now we head over to the Geo5 folder and we pick the most suitable template. So with the most suitable template, we are going to pick the gravity wall, since it's a retaining wall question that we are going to solve. So we double click on the Geo5 software and we move on. Before then, let me display the question to do both hand in hand. So now the first thing we are going to do from here is we head over to the frame section. This is where we are going to work with, and we are going to pick from the frame section every particular tab from here. So the first tab we move on to is project. So when we click on project, we click on project data here, and from there we input the following data, which are here, like the project name, part, description, client, and other data in the following into the project before we start. So after that, we click on OK. Then from there we move on to the settings, and at the settings section, this shows us how we can edit the material section, the wall analysis methods, and also the safety factor method. So since we are going to do some editings, we have to do the editing in this particular part. Head over to the edit section here, we click on edit. Then from there we can see that we are under the wall analysis tab. So we are doing our active earth pressure calculation using coulombs and also using coulombs here. Now let's come back to our question. So we have two types of earth pressure calculation, which is the Rankine and the coulombs. But with the Rankine's theory, it states that before you can use the Rankine's theory, you have to satisfy certain theories. The first theory is the wall that is supporting the soil must be vertically upright, which I think, or per the drawing, our question has passed. And also the cohesion between the wall and the soil must also be 0, which in our question has also passed. And the third one is the soil that is being supported must also be dried, which we can assume is so, since our cohesion is also 0. So now, since our drawing has passed for Rankine, we can equally change the active earth pressure and the passive earth pressure calculation to Rankines. So here I do both by changing them to Rankine. Then from there I come to the safety factors. So the safety factor for overturning, we use 1.5 as the safety factor of safety. Then for sliding resistance, it's also 1.5, and for bearing capacity, it is 3. So from there we move on to another part of the settings, which is the materials and standards. So with the concrete structures in our drawing, we are going to change the code from ACI to BS8110. As we can see, it is here. We change it from here, and since we are not going to do anything regarding to stone or masonry wall, we can leave it here like this, and from there we can click on OK. So now from the settings tab, we now head over to the geometry section. So within the geometry section, what we do is when we click on the geometry, we try to mimic we have several templates of geometries here regarding to retaining wall. So what we do is we pick the one that can mimic our drawing here in our question, and we try to edit the mimic template there. So the one that can mimic our drawing here, I see, is the third template here. So I click on it, and as you can see, it looks some way somehow like the one we have in the drawing. But after we edit the parameters, as you can see in the question, as you can see that it's having a base of 3.5, a thickness here of 0.5, a total height of 5.5, and a 0.5, making 6, and a thickness here of 0.4. When we try to edit this particular template in the workspace, you see that we'll be getting the same thing as it is in the drawing. So this particular section requires a try and error method before you can actually get your particular template to be correct with the one you have with your problem. So after doing my try and error, I'm going to see that we are going to have K1 to be what? 0.4, K2 to be 5.5, K3 to be 0.5, K4 to be, we don't have K4, so we have to K5, so K5, which is 1.1. Now K6 is 2, and S1 is 1200 and S2 is 1000. So now with this parameter, someone will ask, how did I get it? So right at this section, we can see the K1, K2, K3, K5, K6, S1 and S2, and they are represented at the left hand side here. So we now know that K1 here means something here, and we now know that K2 here means something here, and we now know that K3 here means something here, and K4 means something here. So they just shows the distance or the parameters for each and every section of the retaining wall. That's what the K and the S stands for in the particular section of the geometry. So now from here, after giving all this, we cross check to see whether our parameters or dimensions are okay. So the base here is 3.5, as we can see is 3.5, here is 2, here is also 2, the total height is 6, and it's also 6 here, and we can move on. From there, let's head over to the material section. So at the material sections, we are having the unit weight of our material, which is the wall, to be what, 25 kilonewtons per meter cube in the question. So now they say unit weight of the wall, we have to change it to 25. Then from here, the material of the wall or the material of the structure is made up of concrete, so we leave it such. So now from there, we can move on since we don't have any other issue here. So now we head over to the profile section. So the profile section helps us to give a profile to our drawing. So in our drawing, we have two profiles, where the first profile starts from 0, which is on top of the retaining wall, to the base of the retaining wall, and the second profile starts from the base of the retaining wall going downwards. So now the first profile has a depth or a thickness of 5.5 plus 0.5, making 6, and the second profile has not been dimensioned in our question, but we can equally suggest or assume a particular thickness of it. So to introduce the thickness in Geo5, we just click on the Add tab here, and now the depth is starting from 0. So the thickness of the first layer is 6 meters. So we just type the 6 meters here, and after typing it, we add. So we click on Add, and you guys can see it shows. Now the second one, since the parameter or the dimension of the second layer is not given, we can assume that it is 3 meters. So I click on 3 here and also add that one, since the 3 meters will go beneath the base of the retaining wall. So if you still have any other profile, you can add, but in the absence of that, you can just click on cancel here. So from there, we go to soil. So when we click on soil, this is a particular section that is going to tell us the parameters, or we are going to input the parameters of our soil in the video. So you guys can see that the soil here is having certain parameters, and these parameters are the same parameters that's the soil beneath the base of the retaining wall. So now since the soil types are the same, because they are having the same parameters, we just input one type of soil and we input the parameters. So to input the parameters, we click on Add here. So after clicking on Add, we name the soil. So let's say my soil name is sand. Now the unit weight of the soil in the question here is 19 kilonewton. So the 19 kilonewton is the saturated unit weight. So the unit weight needed here is the effective unit weight. So to know the effective unit weight, you just need to subtract the unit weight of water, which is 9.81 kilonewtons per meter cube, from this. So when you do the subtraction, you are going to get 9.19. Then we move on to the angle of internal friction. So the angle of internal friction, which is the phi, is given as 41 degrees. From there, we go to the cohesion, which is 0. But since 0 doesn't work in Geo5, we type something close to 0, which is 0.01. Then from there, the angle of friction struck soil is given here as 25, so we type it. So from there, we give the saturated unit weight of the soil, which is 19 in the question, so we type the 19. And from there, we click on Add. So after clicking on Add, if you have any other soil, we add. In the absence of that, we move on. So now after the soil, we now assign the soil to a particular profile. So since we have only one soil type, when we click on Assign, it automatically assigns to the particular profiles. So from there, we can move on. So as you guys can see now, you are seeing that the drawing in the Geo5 workspace is trying to look like the same, is looking like the one that we are having in our question. So from there, we head over to the next section. So the next section talks about foundation, backfill, terrain, water, surcharge, FF resistance, and other stuffs. So these sites are used depending on the way your question is being structured. So since our question is not regarding to anything regarding our terrain, which is how the backfill is attached to the retaining wall, or whether we have a surcharge, or since we don't have anything like groundwater table in our question, we won't be using any of these tabs. So with that, we are going to head over to the next chapter of the tabs, which is the verification, where we are going to verify our slip and our overturning. So when you click on verification, it allows for data to exceed the pressure analysis, so we can just click on OK, and you guys can see that we are having an overturning and a slip verification, which is telling us that it is satisfactory. So now we can equally check the in detail of this by clicking here. So when we click here, we are going to see the check for overturning and the check for slip. So now this resisting moment here is the moment that the retaining wall has, after all these setups has been done with the question, in order to resist this particular soil. And now the overturning moment is the moment that the soil is given to the retaining wall in order to overturn the retaining wall. But since our resisting moment is greater than the overturning moment, the check for overturning will surely pass. That's the first thing. So now let's come to the check for slip. So now the check for slip, we have resisting horizontal force and active horizontal force. So now, since we can see that the resisting horizontal force, which is for the retaining wall to slide horizontally, is higher than the active horizontal force, which is the force generated from the soil for the retaining wall to slide horizontally, is 34.2. So since the resisting horizontal force is higher than the active horizontal force, it simply means that what the force generated by the soil cannot move the retaining wall in order to slip horizontally, since the resisting horizontal force is higher than the active horizontal force generated by the soil. So this means that what our check or overall check for sliding and overturning is correct. So now we can head over to close and we move on to the bearing capacity. So when we click on bearing capacity here, we can see that our eccentricity is satisfactory, but the foundation of the soil is not okay, just because we didn't add the bearing capacity of the soil. So the bearing capacity of the soil, you guys can see it here, that is the Q ultimate here, which is the 500 kilonewtons per meter square. So I come here and type it here, which is written here as 500. So when I type in 500 and I click on OK, you guys can see that it changed at once to what satisfactory, which shows us that what our soil has also passed the bearing capacity test. So to also check what it means, you can equally click on the in detail here. You are going to see it here that what the force generated or the moment generated here is 76.45 and it's also 76.45. The force generated due to the moment is 1.39 and it's also 1.39 here, and the shear force generated from it is 34.2 and the shear stress is 57.79. So now, as we are having 57.95 as the maximum stress at the footing of our retaining wall, and the allowable bearing capacity of the soil is 500 kilopascal, since the allowable bearing capacity of the soil is higher than the stress at the footing or at the bottom of our retaining wall, we can now say that what our bearing capacity test has also passed. So now to proceed, we click on close here, and from there we can head over to this, which is the stability. So when we click on stability, we are going to see our soil here, and this particular place helps us to analyze for our retaining wall. So to analyze our retaining wall, we scroll downwards to analysis here. When we click on analysis, we are going to see our retaining wall here. So in order to analyze our retaining wall, we click on analyze here, and the FS Bishop does the analysis for us, and after the analysis it gives us a simple drawing here. So you guys can see that slope stability is not acceptable. So let's just increase a space here so that we can see everything clearly. But so now, after seeing that slope stability is not acceptable, the next thing we do is we either change certain parameters of the retaining wall or certain parameters of the soil in order to make the slope stability also acceptable. So one thing about this is we can equally do a printing of this particular drawing that we've done in the Geo5 by equally clicking on this particular point in order to show us the printout of our drawing in this particular Geo5. So this is how it looks like. You can equally save it and you can proceed. So as I said, this is how we do design of retaining wall in Geo5 regarding to foundation engineering. Thank you.